Okay, my peeps, I'm running a little bit slow, a little bit late. Someone graciously gave me their germs and I've caught a cold. But that's okay. What I want to talk about today, Monday, is OR. What we're going to do is put together inequalities so that we'll see what happens with it, and it's important later on in mathematics. Now, some books call it combined inequalities, some call it compound inequalities. Either way is fine with me. Now, OR has three things that can happen. You can have it where both statements are greater than. You can have it where one's less and one's greater. And you can have when they're going in opposite directions. So these are going in opposite directions, but no overlappage. These are going in opposite directions, but there is overlappage. Now, OR in math is like OR in English. If your parents say, look, we want you to clean your room or walk your little brother, you have a choice. You can either clean your room or you can walk your little brother. You don't have to do both. You can do both if you want, but you don't have to do both. So, this, x is greater than 6. Here's that statement. Here's x is greater than 10. Now, OR is wherever there's shading, bring it as part of your answer. So, there's shading here, bring it down. Shading here, bring it down. Well, it's already there. So, when they're going in the same direction, it's the longer one. So, in this case, greater than 6 is longer than greater than 10. This one, they're going in opposite directions, but no overlapping. Here we go, greater than 10, less than 6. It is both. So it would be going in opposite directions. So, same direction, longer one. Opposite directions, no overlappage. It's this. Opposite directions, no overlappage. Now, if it's opposite directions, but there is overlappage, here's greater than 6. Here's less than 10. Now remember, OR is wherever there's shading. So you bring the first one down. Then we bring this one down. Oh, everything is covered. So if you look at this, the question is, where is there shading? Well, there's shading everywhere if you use both graphs. So there's shading from here all the way down, and there's shading here all the way up. So it'd be all reals. So same direction, it's the longer one. Opposite directions, it is just the opposite directions. So think of this. Then opposite directions but overlapping, it's all reals. Everything. Now we combine them. So if I have 2x plus 6 is greater than x plus 10, or negative x is greater than 4. Let's change that to, no, let's keep it. So I'm going to solve it by doing this side, then doing this side, and then seeing what the graph looks like. So this one, holy cow. Don't know what happened there. That wasn't good, was it? Sorry about that. That was a little exciting. So my whole thing came apart. Don't know how that happened. So anyways, so I subtract x. So I'd have x plus 6 is greater than 10. Then subtract 6. X is greater than 4. This one I take the opposite of both sides, or divide both sides by -1. So I'd have x's, switch the inequalities, less than -4. Now here's less than -4. Here's greater than 4. Now, for an OR, it's wherever you see shading, it goes as part of your answer. So here's -4. Here's 4. So I'm going to have to fix this, or try to. So I will be making a part 2. So look for that. There will be only 2 parts with this. Have a good day.